So this unit that we're going to be doing is based around logarithms. But before we get into logarithms, I want to start just by going over exponential functions like this and how we could solve for exponents here without using logarithms. So in this example, we have 2 to the power of x minus 1 equals a to the power of x plus 3. And when we're thinking about exponents and solving for exponents when we have x's as our exponents, something you guys should remember is these become a lot easier if our exponents have the same base. So if we had something like 2 to the power of x plus 1 equals 2 to the power of 3 x minus 2, that'd be really easy to solve, because if the bases are the same, that means the exponents have to be the same. So we could just set x plus 1 equal to 3x minus 2, and then we solve for x, and that's it. With this problem up here, it gets a little trickier though, because our exponents are not the same, or our bases, my bad, our bases. So with that example before, they both have base 2, but for this example, we have base 2 and we have base 8. So our bases aren't the same, so we can't just assume our exponents are the same. But there's a little trick for these problems, is we have to look at our bases, and we gotta think to ourselves, is there any way we could either change 2 or 8 so that they're both the same base? And what should pop in your head is that 8 is just the same thing as 2 to the power of 3. So what we could do is, instead of writing an 8 here, we could put a 2 to the power of 3, and then on both sides of the equal sign, we would have expressions with base 2. So let's do that. We have 2 to the power of x minus 1 equals, and then instead of writing 8 now, we're going to put parentheses 2 to the power of 3. And then we still have that x plus 3 up there. Now we can simplify things a little. This becomes 2 to the power of x minus 1 equals 2 to the power of 3x plus 9. Make sure you're multiplying the 3 by the x and also the 3, not just the x multiplied by both of them. So now we do have an expression that has both base 2 here, base 2 here. So now we can just ignore the bases and solve for x. We're just setting these two exponents equal to each other. So we do x minus 1 equals 3x plus 9. You solve this however you want. Let's see. I'm going to move x to the right side, so minus x. That gives us negative 1 equals 2x plus 9. And then we can subtract 9 from both sides. We're left with 2x equals negative 10. Divide everything by 2. And we got x equals negative 5. So this is our final answer. If you guys see a problem like this, where we have exponential functions, you don't always need to use log. Log is going to be useful a lot in this unit, but just try to be creative, try to think a little deeper, and think about, is there any way that we can have two functions at the same base? If we do, then these become a lot